So I'm going to be talking kind of a little bit in a complement to what Sean already mentioned with the Power BI. Click is another tool that you can use. So I'm also going to talk about one other tool briefly and tell you a little bit about us. So two of the modeling tools that we use, the first one is MATLAB. That's primarily used by our analysts, and we're using that for more simulation validation. The next tool, which I'll go in more detail about, is QlikView. That's used by both our analysts and our customers. So for the analysts, we're using it largely for our validation of the dispatch results. And then once we've done the validation, we can pass it to our customers. They can use the QlikView tool for live presentations or just reporting. And they're these pre-built tools that we worked with them to develop. And then my final slide, I just have one on decision making and for planned outage placement. So Duke, we're a new user of PowerSim. We currently run a 5-year deterministic model. We have 3 jurisdictions. The first is and the largest is the Carolinas. It's 35,000 megawatts. And it's a dispatch to load with kind of an equal distribution of gas, coal, and nuclear with a little bit of hydro and solar. The next jurisdiction we have is Florida. That is primarily gas, 25% coal, and dispatch to load. And then we have our Midwest, which is more what I'm going to be focusing on today. That's 50 units with mostly coal and 30% gas. And that's a dispatch to market. So that one's a little bit easier to do validation on. So there's 2 tools that we use. The first one is MATLAB. This is more of a numerical tool that is for complex analysis. You can use that for more simplistic if you want as well. But it does require some programming knowledge, and it's easy to read in multiple data sources. And all your graphics can be exported for presentations or the data to tables in Excel if you'd like. And then the next tool is going to be QlikView. This is more for slicing and dicing data. It does require a little bit of the programming knowledge if you want to do the application development. I taught myself, then we did a class after the fact, so that just gave me a little more insight. So it's not a heavy programming, but you do need a little bit of knowledge of that. This is best used if you want more simplistic calculations into your graphics. But you can load in multiple data sources in here just like you could in MATLAB. For the analyst, it's great because you can build out these dashboards for them, and so I'll give you an example of a few of those. And that doesn't require any programming knowledge on theirs. They can just take the data, slice and dice it, look at months, variables, whatever format they want, and look at that on the fly. And it's also very easy to export those graphics and data tables. So again, as I said, MATLAB's used by the analyst. We have some programming knowledge is required. So 3 of the slides I'm going to show you today are on how we do a load simulation, a price simulation, and a forced outage simulation. So the first one, and let me say these 3 slides were made by my colleague Amaya. So we wanted to validate the load simulations coming out of PowerSim. So we have 250 simulations that we run. On the left side is the historical data. It's a density scatter chart, so we want to try and match the shape and with the densities in the same area. So on the right side, you can see that it does follow the same shape. The densities fall in the same area. So that's one nice visualization tool to validate that. The next one is a sample of how we can validate our basis simulations. So we have, for example, coal, which is partially contract, partially market. And so in the beginning, we're all contract. At the end, we are all market. Up top, you can see what the contract and market prices are. So we have PowerSim. They do the 250 simulations on the coal. And then we apply this formula, and what we expect is here on the right side. So since we're all contract in the beginning, you don't expect any variation. But towards the end, where you're all market, you do expect the largest variation. And on the right, you can see this is the actual output that we get from PowerSim. So we can feel confident that our basis simulations are being done properly. And then the final MATLAB plot I'm going to show you here is a way we can use to look at our forced outage rates. So we input a forced outage rate that we would expect, and that's shown in the blue bars. And each one of those bars represents a different unit. And the red dot is going to be what the simulated output from PowerSim is. So we can quickly look and say, yes, our forced outages are aligning with what we expect. So our next tool for ClickView, it's used in two different ways. First by our analysts, and we've been able to make an automatic file generation. So once the PowerSim study completes, we have it automatically populate the data in these files. There's other ways you can do it with Power BI, as Sean had talked about. You can load in different studies and select on those. This data, there's a lot of it, so it does take a little bit of time to load it in. So by having it automatically done, if the study finishes at midnight, when we come in the morning, our study will be ready for us. As Sean had mentioned, you can bookmark cases, same with Power BI. You can generate ad hoc tables and graphics if you're more familiar with the tool. You don't need the programming knowledge for this. You just need a little knowledge of how the tool works to build these tables. So we're going to use this for dispatch validation. And for the customer's purposes, once we validated it, we hand off this tool, and it has all these pre-built plots and tables, that they had asked for and that they're kind of used to seeing, separated out depending on what their requests were. So they can select by either time granularity, they can look at the unit groupings, or individual units, or different reporting variables. So this is one of the snapshots of the tool that we've built. So as you can see on the top, there's a bunch of tabs. These are all different asks and different views that the modelers wanted to see, but we didn't want them to have to build each of these plots. So this is pretty representative of what a lot of these tabs are going to look like. It's just going to be different variables loaded in. So on the left side here, these are all the variables that they can choose from. Similar to what you saw with the Power BI demo, you can select on all your different variables. You can choose your item in here. Typically, this would be your unit level under the item comp ID. I've kind of scrubbed the data, so it just says coal or gas or must run. And then your item ID would be more at the plant level. You could select on different number of stats or different sim reps. You can also do time granularity down here. So what I've shown here is a plot for, you can either look at generation if you clicked on this tab, or capacity factor. But you wanted to view that in terms of, what's the capacity factor, what's the fuel consumed, what's that total cost. So if those don't align, you could say, well, maybe there's something wrong with my dispatch. And then the fourth plot, I've allowed them to actually choose another variable of interest that they may want to look at. So in this case, I've chosen, well, is the unit in the money or not, since this is a dispatch to price. So when your prices, when you're more in the money, your capacity factor is higher, which obviously you're consuming more fuel and your fuel cost is going up. But likewise, you could look at, if you wanted forced outages, you could put that on the other chart. There is another tab, which I'm not going to go into, is this ad hoc look. That's more what I use. So I'll select a bunch of these different variables in whichever way I see fit. But you do have to be careful when you're doing this, because if you select the things that didn't make sense, you could be adding data and you would receive some garbage. But on these, what I've done is I've actually locked down these variables, so to try and kind of make it foolproof for the user. So another chart that's a little bit of a different flavor, and this is really good to look at either the load, or dispatch to load, or dispatch to market. So in this case, I have a dispatch to market view. So I'm having them look at the capacity factor on this side, or if I wanted, I could tell them, okay, I want my y-axis to actually be generation, so you could switch up that variable. And then on the x-axis, in this case, I'm looking at the spread. But if you were in a dispatch to load case, you could look at, click on load, and then this would switch to a load view. If you were in dispatch to load and you wanted to say, well, what does my coal unit look like compared to gas price? You could select your gas price. If you wanted to look at what is my gas versus gas price, or my coal unit versus coal price, then that would just be like an input fuel price. So this is looking at on the iteration level. So on this case, as you are more in the money, you would expect your capacity to increase. One great thing about Click is, there's these couple data points down here, these forced outages. And a nice way to see this is if you just kind of draw a box with your cursor, then you would be able to zoom into those specific data points. And then I have a table down below, which you could select any variables that you want to look at here. I've chosen capacity factor, forced outage, the spread, and the planned outages. So when I clicked to zoom into those specific ones, then it would come up, well, what's my forced outage or what's my planned outage? And I could quickly see, okay, yeah, that makes sense. Some of the other things I didn't mention that Sean had mentioned you can do in Power BI is, actually that's cut off on that chart. Let me go over here. If you're familiar with Excel, you can export to Excel by clicking that little Excel button. It will not export the actual figure, though. It will export the underlying data. And this can be used, I like to do this if I wanted to add on other data, such as history, or we have a deterministic model that we're using, so I can add on layers of data that way. The other thing that's really great about these is, say you want to look at it in a table form. There's this fast change button, which you can have it program in whichever chart you want to look at. If you wanted to say, maybe I want to see this as a bar version, maybe I want to see it as a table, I would just click that button and it would just change the plot. So very super easy to use, able to get different views, different variable views. Another thing that I think is really cool, rather than clicking your month or your year that you want to look at, if you, again, highlight with your cursor this time range, it's going to zoom into that time range, and all these charts are going to update for you. So I've shown you, how you can look at it in time granularity for the different stats or the different iterations, or how you can look at a variable versus a variable. Sometimes you want to look at compared units. This can be used if you have a group of units that should behave similarly. You could select all those similar units, put it on this chart. You could see it on time for a set, say in this case I have a mean for a capacity factor. And you could make sure, okay, my variables, they are all behaving as I would expect. Another way you can use this, and this is typically how I like to use this figure, is if I want to look at, say, prices. Maybe I think all my coal prices should be about the same. I could put down all my coal prices here, and if any of them are very different, it's a quick visual way to say, hey, something's not right with that price. You could do that with load. You could do it with all your units. Sometimes I do this if I want to look, another way to look at the forced outages. You could select all your units, and if there's a forced outage rate that's huge, and okay, well, let me look at that. Let me look at that specific unit. What, is that the actual outage I expect? So that's a quick way we use to debug and validate our dispatch decisions. And then once we validated that, we can pass this along to our modelers, which they can use for presentations. And what's great is you can use this during a live presentation. So if you ask me, okay, well, great, you have the coal, gas, and oil unit on here, but I want to look at all your coal units. Okay, I can just select all my coal units. Or I want to look at it in terms of net position, which would either be generation or load, depending if you're looking at your assets or not. And you could plot that. So this is a similar feel to what you'd have in Excel or Power BI, but it's slightly more complex. So sometimes you just can't do easily what you want to do in Click. Now, you can program other things. We haven't gone that route. But what I can do is I can make all my data selections in Click, just like you would in the Cube or Excel or a pivot table, and export that data to Excel. And then you can either import it to the MATLAB tool if you wanted to do more complex calculations, or export it to Excel if that's more what you're familiar with. And you can layer on historical data or deterministic data, perform any additional calculations, or other graphics that may be a little more difficult to do in Click. So one of those graphics is the histograms. You can do a histogram in Click, and I do. It just takes a really long time to load that data. So what I've done here is I've exported all the iteration level data. I've broken it up by years, and so these plots are all done in MATLAB. And I've layered in on the stars. These are the historical mins and maxes that we've seen. And the blue line is going to be, the red line is the deterministic run. So you can see that the coal burn has been is steadily decreasing, as we expect. We see that when we look at the historical data, the trend of coal, we're burning less and less. So, in 2018, we went to 180 million in coal burn, and then down to 160 in 2020, and continuing to decrease. And both stochastic and deterministic models are telling you that. And also, your coal is becoming a little more uniform there.
Your mic fell down and it's making a lot of noise.
Okay, so another chart, I mean, this is the Excel data exported to Excel, or sorry, the click data exported to Excel. So this is for a must-run coal unit. Up here we have our deterministic case, and what these plots are really useful for is our customers are used to seeing all the deterministic. So we're trying to get them familiar with what you're going to get out of the stochastic model. So our stochastic mean for a must-run coal unit, very close to what we have our for deterministic median similar, P10, P90. Some of these other spikes, this is a higher forced outage rate. These are some planned outages that are occurring. And then there's one point up here. Actually, I think there's a few of them in this plot. So in our deterministic model, we model forced outages in not the best way. So in this case, when I dug into this, this specific case, I looked at, okay, what's going on in this month? Why is my deterministic higher than my P90? The forced outages were just a lot lower in your deterministic model in that specific month. So that was showing up in it crossing the P90 case. And then finally, another chart that I wanted to show you, kind of how we can use stochastics is in our deterministic model, we have a marginal unit that doesn't run that often. And currently, we have our planned outages scheduled in April for this unit. And that looks fine based on your net revenue. Okay, we're not making that much money. Let's schedule it in April. Now, if you look at the stochastic version, though, okay, April's low, but you can do better. November is actually lower net revenue. So you can use it in maybe, should we switch moving our planned outages to a different month that you wouldn't necessarily have seen in that deterministic case. Now, maybe there's other reasons that you don't want to move to November. Maybe you have other outages scheduled, but it's just another way that we can use stochastics to inform our customers. And that is all I have. Any questions? Yeah?
More of a clarification. I'm assuming when you say customers, you're talking about internal customers, internal users of this calibration results inside of you.
Right. So we'll pass this to our modelers that currently run the deterministic model. We can use it to present to a risk group. And in fact, the first round that we did, we used this tool and kind of did excerpts and presented that to the risk group. You can present this. We get a lot of questions from the people doing our fuel purchasing. So you can show them, the plots, the ranges of, here's what your fuel burns could be. So yeah, when I say customers, it is kind of a wide range, but pretty much all internal. Yeah.
So ClickView is a generic data viz tool, and you built an application within that to accept this power data?
Yeah. So we Click, you can read in all sorts of all types of data. There's, you can read in different tables. We wrote a SAS script to export data. It reads that in, and then I custom built all the different graphs.
So you built a dashboard.
Yep.
Have you guys used anything like Spotfire or Tableau or any of those other tools that are out there for data viz?
Our group has not. Within Duke, I don't know, Matt, do you know if we're using Tableau anywhere?
Pretty much everything gets used somewhere.
So, and I think Power BI was mentioned initially when we started looking at it, but Power BI just it really wasn't there. One other thing that I didn't mention is like Power BI that you can put on for more mobile, we have put this out on a server, so people can go out to a web link and look at that, and they can't make changes, which is great because they're easy to make changes or delete a chart. So whenever I pass this on to someone, I lock it down. They can make changes to look at different data, but they can't save it. So, because I don't want to come back and all my charts are gone because aligning everything and trying to get it just right. Any other questions?